Hello everyone. So, in this series, what we want to do is start getting used to Python. And Python is an incredible language. There are a number of scenarios where it is used. It's very convenient. That's the biggest plus point for Python. It's very easy to learn. It's very convenient. You don't have to understand the underlying architecture of the machine or any device that your code will be running on. So it's really handy, and it's what's called as a scripting language. So the difference between scripting language and compiled languages is that you'll have to sort of understand the data types and the data representation, in-memory data representation for compiled languages. Whereas in scripting languages, you don't have to understand all of that. Basically, you can write your code and be done with it. Which is why it makes Python really convenient and easy to use and also easy to learn. So, few areas where Python is used is one of the things it's used for is web development. It's used in server-side web development. It's also used in software development in uh, popular fields like data analysis and machine learning. And it's also used for mathematical and scientific reasoning. That's also it's used for. It's also used for system scripting. So now this is a particular area that is really close to me because this is what I do in my day-to-day job. I use it to write scripts, to write automated scripts to do stuff for me. And right, so why Python? So basically, Python is what we call it as it is regard it is the interpreter is able to run your code regardless of the operating system or your underlying instruction set architecture, right? So it's cross platform, that's what it's called. So it's first of all it's cross platform. You could use a Python script that is developed by someone else on some other machine, and you could use it directly for your machine. So it's very user friendly in that sense. It's cross platforms. Let's say it can be used on Windows and then Mac OS, and then it can also be used on Linux. It can also be used on Android apparently. Well, but then Android is again just Linux. So it's easy to understand. It's very intuitive. It's easy to understand. It's very easy to understand in that it has a very familiar syntax to how humans would communicate. Obviously, it's not going to be exactly the same. If that would be the case, then you could say that it's A2 and general AI, right? And it's very convenient. Let's say what I mean by this is, let's say in some other language, let's say C++, if you would take 100 lines to achieve some task, in Python it's very possible that you could achieve that task in less than 20 lines or so. In less than 20 lines or so. So makes it really really convenient, and it has n number of packages in its package repository. That's why we want to learn it. It's very convenient. It's easy to understand. It's cross-platform, right? Now, so let's just start with the technical details of how we would learn Python. So one of the things that you would need to understand about Python is that it is an indented language. That is, if you were to so in any programming language, so I'll start it like this. So in any programming language, let's say you write code in pieces or you write code in blocks. Let's say there is some block here, block, and how you would represent that block is by in many languages you use curly braces. So this would mean that your piece of code, this block, will belong. All the code that belongs to this block will lie inside these curly braces. However, that's not the case with Python. So for Python, what you would do is you would use this word block. I mean, this is not actually a word, but assuming that this is a construct in Python, most likely you'll use a semicolon that will mark a start of the block, and then you will write your code indented by some number of spaces. Let's say some number of spaces, you would write all of your code inside that block, right? So that's how you would represent a block in a Python. For example, I'll take a very simple example here. So this code probably won't run, but it would make sense. I'll just in a minute I'll just explain why this makes sense. Let's say there is some variable count. Okay. Now we'll get into detail what count is, what if is. You don't need to bother with anything. But for now, just assume that this is some code in Python that we're writing. Let's say if this is greater than 0, and then we'll mark the start of the block, and then we'll do something. We'll do something else, and all of these things. So we'll write instructions inside of this indented block. So that's how we will represent a block inside our Python programming language, any block. And we'll get into details what all of these things mean. So we've not yet started on what if means, or what count means, or what these operators are, why we are using it greater than 0. So that's where we need to dive deep into the inner workings of Python and how we can use it. Right. So this is about Python syntax. So let's start by variables first. So let's start by variables. So what a variable really means is it's a storage location. Fundamentally, it's a storage location. That's what it is. It's a storage location. Now the way this works is, let's say there is, of course, you have some machine, there is some underlying machine, and then there's some memory inside of it. So let's say we can think of memory as a chunk of blocks. We don't need to dive deep into the memory architecture and all of those things, but let's say our memory is just a chunk of blocks, and what our variable really means is it's a compartment where we can store values. Let's say I would store a value, something like a 5, in one of my variables or memory locations, and that's what I would say as 5. Let's say I will define my variable as x. Let's say x equals to 5. What this means is in mathematical terms, in mathematics world, this would mean that x is 5. The variable x is 5, and then let's say. But what this means in computer science world is that it would mean that there is some memory location which is denoted by x. So okay, this is very high level representation of how we think about memory, and 5 is the value that you're storing in this memory location. So this value 5 is it's getting stored in this memory location, and down the line inside of your program, let's say if you were to rewrite this into something like x equals to 10, then what will happen is this 10 will get stored in your memory location of x. That is, this 5 will be erased. It will be erased, and now you'll store 10 over there. So this means that it's the same memory location, but you're just updating its contents. The contents of that memory location have been updated. And let's say something like, we might have something like y equals to 1, and then later on we might have something x equals to y plus 7. And let's say there is some memory somewhere else which has which is y, and its content is 1. That is, we've stored the value of 1 over there, and then next our instruction says that x should be equals to y plus 7. That is, we are trying to update our value of x by adding 7 to the value of y. So whatever is the value of that at that point, we'll read the value. So this is what's called as a read operation from memory. So we'll read the value, we'll substitute 1 over here, and we'll do this addition 1 plus 7, and this 1 plus 7 will turn out to be 8, and then we'll assign the value of 8 uh, into the excess x memory location. We'll update the excess memory location with the value that we have computed, that is 8. So that's what a variable is. It's essentially a storage location. It's a unique location. It's a unique storage location. That's what it is. Right, so that's what a variable is. So we can store values inside of it. So if you will do something like x equals to 5, and later on somewhere you do x equals to 10, that would mean right. So that would mean that you're updating the contents of your memory location x. Right. So that's what a variable means. I think it should be very clear at this point. So moving on, variables can be used to store data types of different types. Okay, now this is what we need to understand. This is quite fundamental to Python. The types of data, the kind of data that we can store. So there are basically there are fundamental types. Fundamental types. Those are also called as inbuilt types. You'll hear about this from quite a few people. All of those people who work with Python, that there are inbuilt types, and then there are let's say user-defined types. User-defined types. So these are not built into the programming language itself. This is what the user has to define. Right. So let's first understand what are the fundamental types. Fundamental types. What are fundamental types? So fundamental types are like numbers. These could be numbers. These could be words in English. So this particular phrase, words, I'm using it in context of human language. When it comes to computer language, we call it as strings. We call this as a string. A string is just a collection of characters or alphabets, or it could be any characters. It could be alphanumeric characters. It could include special characters. That's what we would consist of a string. So a string is essentially a collection of characters. Collection of characters. Characters. Right. So that's what it is. Then a simple fundamental character. It could be an alphabetic character from A to Z, let's say from small a to small z, or it could be capital A to capital Z, could be 0 to 9. These may be numbers too, and these may be characters too. So there is a character set, it's called as an ASCII character set. So one of the things people, usually beginners, are confused with is the digit 0. This is a digit and a character 0. So this is a character and this is a digit, right? So a character is going to have an ASCII value. So what is ASCII? ASCII is American Standard Code for Information Interchange. So it basically just maps every character to a given number. I don't exactly remember what the ASCII for 0 is, but I'm pretty sure that ASCII number for small a is 97, small p would be 98, and so on. So this is how we think of characters. So they are basically encoded as integers, as numbers in our system. Of course, at the end of the day, we all know that information is represented in zeros and ones in a machine. So this is something that's quite fundamental, and I'd like to glance over it just quickly. So in a digital, even in not in analog systems, in a digital computer, information is represented in zeros and ones. So for example, this is a very crude example of how information is represented, and probably we'll go through this, or maybe just immediately we'll just quickly go over this. So let's say if I want to represent the number 12, so this is how I might represent it. So this is how the machine usually represents it. So this is what's called as a unsigned representation of 12. This is what's called as an unsigned representation of 12. So you don't need to know all of this in order to understand Python, but it's just it gives you a really good understanding about the nature of programming and programs themselves. So the way this represents 12 is usually you give indexes to these positions 0, 1, 2, 3, and then simply try to do a summation 2 into whatever is, sorry, this is the digit 0 into 2 raised to 1, so this would be 0 into 2 raised to 0 plus that is digit 1. It's actually called a bit. We won't call it a digit because digits are from 0 to 9, right? So let's call these bits. It's a more accurate representation, and we'll raise it to the power of 2 because the index is 2 over here, and for this one the bit is 1 and we'll raise it to the power of 3. So we'll add all of this to 2 raised to 3 would be 8, and 2 raised to 2 would be 4, and there are 2 zeros over there at the end of it, so it will be like 8 plus 4 is 12. So that's how we represent 12. You don't need to know this in order to understand how to use Python and write Python programs, but eventually at some point if you really want to dive deep into the software engineering world, this is something that you should be comfortable with. Anyways, so this is how we represent information in a digital computer. It's represented using zeros and ones. Again, there's a whole theory to how this is done, but that's beyond the scope of our programming lesson on Python. Right? So that's the actual type. It's not a type. That's the actual representation of how information is represented in a machine, but we can derive types out of it. So the fundamental types that we were talking about were numbers, strings I told you is just a collection of characters. Again, a character, we thoroughly saw what a character was, but the numbers could be of they could be integers, and then they could be decimal numbers. Numbers like let's say 2.73 or 3.14, the numbers that have a decimal position over here, and the numbers that are not whole numbers, right? They are not whole numbers. So something like this, right? 3.14, it could be minus 7.23. These kind of numbers are called decimal numbers, and in the world of in the programming nomenclature, what we use instead of decimal is we call them as floats. So we call them as floating point numbers, or we call them as doubles or floating point numbers, and the distinction between doubles and floats is again beyond this introductory scope, so we'll try to revisit as and when we require the distinction between floats and doubles. So basically floats and doubles again, okay, so let's visit it later on. This will complicate things for an introductory lesson. And integers are simple numbers that we are used to, let's say -3, 2, 1, things like these, 0, -32, 100, These are numbers that we are all used to on a day-to-day basis. We use them quite frequently. So these are all integers that can be represented inside of Python numbers. There are complex representations. So there is something called as a complex number representation, but we won't get into at this point. So let's see what a string is. A string data type is these are all representations of data. These are all data formats. This is how we might represent the data. We might represent them as numbers, strings, or simple characters, right? So a string is basically a collection of characters. So let's say something like hello world, hello, and world. The reason I encapsulate this within these parentheses is because this is how we represent, or this is how we assign a string to a variable. We either use a double quotes or we use a single quote in Python. So this is very specific to Python. It may not be applicable to other programming languages. Certainly, it does not apply to languages like C and C++ and Java. But this is very specific to Python. But it's only syntax. There's nothing too difficult about this. So there are about 5 and 11 characters in this string. So the first one is H, the second one is E, third one is L. Again, there's an L, there's an O, and if you notice, there's a space. So a space is also a character. A space is also a character, right? So there are 6 characters at this point: 7, 8, 9, 10, and 11. That's it. And this could also be a string. Let's say @937 exclamation and a, let's say, euro sign. It's an euro sign or a dollar sign. Anything is fine. So these are also characters. So @937. By the way, these are not digits. Don't think of them as digits when they are encapsulated inside of the these semicolons or these double quotes. They are not digits at this point, even if it's written as 739. So this is not 739 as in the 739 the number. It's 739 that's written in it's a 739 string. That's what it is. It's a 739 as a string, and it's not a 739 number. The number 739 is quite different because you can do numeric operations with 739, and you won't be able to do numeric operations with the string 739, right? I mean, there are crazy languages like I don't know, JavaScript, who allow you to do that, but I think JavaScript is just plain out crazy. I think that's a horrible language. Whoever has made it, but it's tremendously useful. So no hate to JavaScript, but then yeah, I think it's quite terrible in the way that it allows you to do quite some disturbing mistakes, which should ideally have been avoided by the nature of the language itself. But anyways, keeping that aside, this is the point that I was trying to make. It's a string and this is a number, right? That's what the strings are. And again, characters are just characters. That's what they are. A, B, could be small z, it could also be capital A, it could be capital Z, it could be the character 0, it could be the character 9, it could be the character ampersand. And there's a peculiar fact that everyone who learns Python and any programming language should know about characters, is that, as I said earlier, they are represented as numbers in the system, and that representation is given by what's called as an ASCII code. So every character has an ASCII code. So let's say the ASCII code for the character A is 97. Subsequently, for character small b, it should be 98. If I remember correctly, for capital A, it should be 122. I'm not very sure. Oh, I think it's 65. Yeah, right. Yeah, it should be 65. Uh, and then so on. For capital B, it's 66 and so on. Please correct me if these numbers are not correct, but I'm pretty sure that it's 97 and 98 and so on for the small case numeric letters, and 65 and 66 and so on for uppercase numeric letters. Right. So those are the fundamental data types that we have at our disposal to begin with. This is a good starting point, right? So at this point, what we've done is we've gone through a bit of a theory. So let's fire up our code terminal and let's try to understand how all of this would work inside code, right? So we'll write some code now. I'll show you how. Okay, so first of all, before we begin, I'll show you how Python can be installed on our systems. So this is a Windows machine, and what you can do is you go to Python download, right? Something like that. Right. So this is where you could go, and you should visit this link. Right. And you are free to download a version of Python. I usually prefer to not download the latest ones, but you could go ahead and install it just fine. It should work just fine, and it shouldn't be too much of hassle. Well, let's try to do that. Because I already have a Python version of Python installed on my machine, it should be pretty easy. So once this is installed, what we will do is we'll open up environment variables. So first of all, we'll install the Python, right? So let's wait for it to download. Meanwhile, my file explorer is coming up. Right. So I guess it should be somewhere in local disks, and then you try to install Python somewhere. Usually should find it in. Okay, so this is where I've installed it in local disk C. You go inside. I think it should be. I don't exactly remember where it is, but yeah, that's right. This is where I have kept my python.exe. You need to find a folder where you have kept python.exe and simply copy the whole thing. Copy the path, the Python path, right? You just copy it. I mean, you need to copy the whole thing. This is what you need to copy. Path to python.exe, the executable binary. And then what you do is you simply open up environment variables. Environment variables should be edit system environment variables. Search up environment variables, and this is what should show up. You go to the advanced tab and you open environment variables and you add a new one over here. Okay, so no, don't add a. You don't need to add a new one over here. What you have to do is you have to go to path, and then you can see that you can add a new entry over here. But I don't need to because I already have. As you can see, it's I have python.exe already given the path to python.exe, and in this path variable as well, in the system variable path, you open up, you add a new entry to it, and just give the Python path that we have recently copied. I don't need to do this because I've already done it, and you simply OK and close it. and it should work just fine out of the box. You can also check it if your Python is working by giving this command python hyphen version. It should give you a version, right? So it does give you. So it says that Python 3.10.4 is installed on my machine, right? So I've opened up Visual Studio Code. So I've opened up a copy of Visual Studio Code. You could download this editor from. It's a free editor that anyone is free to use. You can simply go over to Visual Studio Code and simply download it. I already have it on my system, so I don't need to. And that's it, because it makes it quite easy to work with. Anyways, so I'll just let's just open up a new folder. All right. So Python. No. Right. Right. So let's go inside Python programming, and I will open up inside my Visual Studio Code editor inside this path. So that should open up a new editor, and it has. It's good for us. So we've opened up a Python programming environment inside of Visual Studio Code. Right. So let's write some simple Python. Let's call it basic.py. Right. So one of the first things that we want to understand is the variables, right? So as we said that there are a number of variables, and we can name these variables as we choose. It's completely based on us how we want to name these variables, but it's always recommended that we name the variables that make sense. Basically, it becomes easier for someone else to understand. So let's say something like if I'm writing some mathematical program, I will probably use very simplistic naming for my variables. Let's say x. So I would say that x equals to 9 and then y equals to 10, something like that, right? So these are two numeric variable declarations. So let's say 10.23. So this is what's called as x is a variable which is an integer, y is a variable which is a float. These are floats are integers at the moment, but if I were to change them, let's say x equals to 3.33, then the type of x would change. But because this Python is supposed to be simplistic, I mean it's convenient language, and it's actually non-strictly typed language. So you could probably assign even a string to the variable which was previously an integer. So let's say hello. So this is like son, again assigning x with a different data type. So I'm changing the data type itself. So previously x was 9, which was of integer data type, but now I've assigned it to the data type hello. So the Python interpreter or the Python compiler, well, the compiler, it's not correct if I say Python compiler, because it's essentially an interpreter. So there's a difference between interpreters and compilers. We will bother with it when we feel the need to understand the difference between the two. So let's say, right. So that's the point that I was trying to make. So x is 9 and y is 10.3. Now, one of the fundamental things that you would like to do in Python is to be able to see or print the result of your variables, or see the states of your variables. So the state is a much better word, because at any point the state of the same variable could be different, right? So let's say I want to see what the content of the variable x is. what I'll simply do is write a function. This is an inbuilt function inside of Python, that is print, and I can give a string inside of it. So this function is going to take arguments. So I can pass a string inside of it. So this is just going to be a prompt, or it's going to be for sake of easy understanding. You might use strings and integers and all kinds of objects. I think the later objects are also directly printable unless they are user defined. Anyways, so we say that x equals to, and after you're done writing the string, you give a comma. That's what we use to separate the data type string and the integer. X is, this is what, x equals to that. And similarly, we'll write another print statement to y equals to. So these are all instructions. So these are all instructions. So x equals to 9 is x equals to 9. This is a assignment instruction. Print is a print instruction. That is, we are trying to print things with it. This is again an assignment instruction, and then again it's a print instruction. Why? Right. And now we want to run our simple program. We want to see the output of our simple program, right? So what we do is we use this command Python 3, because we are currently standing on the Python version 3. So we are on Python 3, the program name basic.py, right? So this should print okay. For some reason the term is not recognizable. Okay, for whatever reason this is not actually using my existing Python, but there are Visual Studio extension where you could download a Python extension from Visual Studio, and I'll show you in a moment how this works. So you can simply go over to this extensions tab and type Python, and a Python extension should come up. There it is. So this is the official Microsoft Python extension in Visual Studio. You could simply install it and use this button over here to run it. Right. Great. So I got why this was not working. Basically, I have multiple versions of Python installed on my machine, which is why it got confused as to which version of Python should be used. So instead, what we can do is we can simply copy this command. This is the Python's executable, that is the path of the interpreter, and then simply give our basic.py. Hope this works. Right, it does. But this is more convenient. Just use a button and runs the program for us. Great. So we'll try to run the program once again and see the output. Right. So it says that x equals to 9 and y equals to 10.23. Now, what I want to do with this is let's try to reassign x. We are reassigning x to a string variable. Let's call it hello. Now let's check what x has. X equals to, and we write this. So by the way, the print statement is going to implicitly add a new line. So a new line means it will try to print the next print statement below the current line. So it will print it on a newer line. Try to execute this, and this is what it says. It says x equals to 9, and then x is 10.2. Sorry, y is 10.23, and then x is reassigned to hello. So this x equals to 9. This got discarded. So let's quickly take this program and understand how things work internally. So I'll bring up my notebook and I'll paste this here. Right. Paste our little program over here. Let's try to understand how this happened. So what we did early on, as I said, variables, think of variables as memory locations. Think of them as boxes where we keep things in, where we keep stuff, right? So in Python, there are boxes. The boxes do not have a fixed size, right? So you can keep only one thing at a time, but you can keep different things. It's not like you cannot. For example, in C and C++, these are strongly typed languages, and even Java, you cannot store a string inside a variable which was declared as an integer. So you have to store only integers for variables which were declared as integers only. But here we don't have those strict type names, which makes it easier for us to store multiple types of data in the same variable. So let's understand this. So let's consider X as a box. At the first statement it stores 9. Let's understand Y. Let's think of Y as another box which stores 10.23. So this is where we are. X is stored as 9, Y is stored as 10.23. But later on we are storing this string hello inside of X. So what this does is, this is going to remove the value of 9, it's going to erase the value 9, and it's going to store the string hello. This is how it's going to work, right? So it essentially erases the memory location and stores the updated value, right? So yeah, that's pretty much about variables, right? And let's try to have some more variables. Let's say fz. So let's say z is a variable which stores small r. Let's try to print it. Let's try to print z. You could print this value z in on itself, or you could choose to be more elaborate and write something like z is or z equals to. It'll print whatever. So it's going to display string however you want it to. Let's say we define another string here. Before that, let's say a. So I call a is some other variable, and I'll call it as world. I define it as world, and then I simply try to print a. Print a. Also, there is one important thing that I need you to understand is that you can only use variables that have been previously defined in the program. For example, if I try to use z, which is not previously defined. So when I mean by previously defined, what I mean is from the point of use, from the top of the program to the point of the use. If you haven't defined that variables, if you haven't defined the variable, you cannot use it. And the reason is quite simple. Let's say there is some memory location. Right? This is some memory location address, and there is nothing in this memory location at this point. But you're trying to use it. So I'll call this Z. You haven't defined it, but you're trying to use it. Let's say print. You would write something like a print Z. But you haven't defined Z anywhere previously. So how can you use it when it's not even defined, right? So that's an illegal case, and even the Python interpreter is going to crash at that point. It's going to say that this is an illegal use of this is semantically wrong, although it's syntactically correct. Again, the difference between syntax and semantics is that syntax is like you're writing the statement itself wrong. Let's say you forget to write the closing bracket, so that's a syntactic error, which means the grammar of the language is not correct. That's what it means. It means it expects you to write the correct representation of the function form, print. But this is a semantic error in the sense that this is a logical error. What this means is, it means that you haven't defined Z, but you're trying to use it anyway. Let's just see how the interpreter, Python interpreter reacts to this, this is going to crash definitely. So this is what it said. So it executed everything up to this point, right? So it said x equals to 9 and it said y equals to 10.23. Then again the reassignment of x equals to hello. But the moment you try to print z, it says that name error. It says that name z is not defined. So you have to be very careful in how you're using your variables. You shouldn't use your variables when they haven't been defined. So it's going to give you, it's a very trivial error, but it's possible that we make such a mistake. Anyway, so moving on, we'll try to get this program to work. Right. So now here what this says is x equals to 9 and this works because we have defined a and it's being used at a later point. So it prints world. So you could print string, or you could also print all these numeric data types. It's also possible for us to print the characters. So z is r. Right, so this says, so this point it says z is r, because the reason it says z is r is because the character that is being stored in this memory location z is r. So I'll explain this on my right. This is how it's supposed to be. Right. So we'll draw the memory diagram once again. Let's say this is x, and we store 9 in the x, and then we have another variable y that we stored 10.23. Then we are reassigning x to the string hello. We are storing. Okay, so strings are without this quotes, but for the sake of syntax, this is how it's written. They are written in the quotes. Double quotes or single quotes in case of Python. Either of them are fine. Then we define another variable a, and then we store the string world inside of it. We print it, and then we request another memory location, that is call it as z, and we store the character r inside of it. So this is what it says. So z is this variable z. So what this is going to do is it's going to read from this memory location, and whatever is stored at this memory location, it's going to print it. So it's going to read r from it and it's going to print r. It's going to read. So this is a store operation. So okay, so this is quite fundamental to in all of computer science. So there are something called as memory store and loads. Okay. So a store operation is going to store some value at some given memory location. So let's say there is some memory location x and there is some value y. So this is, let's say this is what your system memory is, and system memory is being addressed. It's addressed by addresses. So 0, 1, 2, 3. Think of these as addresses. And let's say x is some address. X is some address, and let's say y is some value 10, and we want to store our value over there. So we can store this value. So store is basically writing to the memory, and a load, let's say load to a from x. So a load to a. So a would be some memory location again, and x is, it simply means it's going to read from this location and write to here. So it's going to copy that content. So this is some memory location a, and it copied the content of the memory location x. Memory location x had the content of 10, it's going to copy to a. So basically store, think of store as like this, x equals to 10, and think of load as like this, a equals to x. So x is going to be 10 is going to be stored in x, and x is going to be read from, and x is going to be read from and stored into a. So this is how this is going to work. So that's called as load stores in programming and in computer science in general. Right. So yeah, I guess this is pretty much it for the introductory lesson. I hope you understood this. Hope to see you soon. Thanks.